All right, I think we're all set. So Terry, would you like to introduce Doug and how you came to discover him and his work, and just give
So
us a little intro?
I do not have your CV in front of me, Doug. So I think you might have sent that around, Keith. But I will just say I met Doug many years ago down in the Philadelphia area when I lived down there. Doug was, I believe, the co-founder of the Internet Capital Group. Is that correct, Doug?
Yeah.
Which you can read the history on, was quite an amazing company that grew tremendously in the early stages of the internet boom. And Doug has always been very involved in the technology space, and had adopted early understanding blockchain and certainly AI. And I had recently heard Doug on another podcast, and thought his understanding, especially from a systemic and 30,000 point perspective view, 30,000 foot high view, was really worth our sort of hearing what he has to say and how it could apply to what we do as legislators here in the state, and what we see coming. So
Great.
You want to take it away from
Great,
there,
Terry.
Doug?
Yeah, Terry, thanks for the intro. Yeah, I've been in the software industry for 40 years. I started several companies, ran several companies as a VC for 20 years, and I actually was building AI systems in the 80s. I built my first neural network, I think, in 1985, which didn't work very well, but I sort of built one. And I'm also involved in the infrastructure build. I'm on the board of one of the OSATs, which is a key part of the semiconductor industry, and we're building as fast as we can, as much capacity as we can in Arizona, Taiwan, Vietnam, and around the world, just to be able to meet demand. We're a TSMC partner in around the world. We're an Nvidia partner, Apple, et cetera. So we've been sort of in the thick of it. My expertise is in AI, crypto, and software businesses and entrepreneurship, if you had to just sort of sum it up. So first of all, thanks for having me. I mean, and thanks for allowing me to speak to your beautiful state. I guess maybe I'll talk for 20 minutes just to give some sort of skeleton, and then we can sort of open it up for questions, just to give an overview. And the goal today is sort of to just give you a framework. There's so much news every day. It's so confusing. There's doomsayers, there's like incredible optimists, and sometimes it's the same person. I just want to sort of let you walk away with a framework of how someone that's involved in the space, like from an investment standpoint and have to make hard decisions, how we look at it and how we sort of map all this stuff so that we can, as news comes in, we can say that's irrelevant, or that's actually really important, and here's how it fits in. So I guess the foundational question is, why are these companies spending trillions of dollars, to build out data centers that they're going to have to rebuild mostly in 3 to 5 years, because the half-life of these chips is very small. So, there's this frenzy going on that look like pretty uneconomic decisions. And we had this with the internet, with the dark fiber built out. Global Crossing, some other companies didn't end well. They laid all this fiber, and then there were mass bankruptcies. And we benefited from that because we're all using that fiber to even talk today. So is this a repeat of that? Now, it's really, if you take the perspective of you're the CEO of Google, right? And you know that whoever wins this AI race is probably going to control a large part of the global economy for the next generation, just as Google did, starting in 1998. And if you get it right, your stock's going to be multiples of what it is today. If you get it wrong, you're Xerox, and who invented the technology to put them out of business. Like, it's a very high stakes game right now, which and it is a bit of a winners take all market. So if you're the CEO of that company, do you slow down and play it safe, or do you move fast and maybe start breaking things? And it's sort of the ultimate prisoner's dilemma we're all trapped in right now, at a company level, country level, and even at an individual level. Once one player accelerates, everybody else has to follow. That dynamic, sort of what I call relentless race for intelligence, is what's driving everything we'll talk about. The economics, the geopolitics, investment landscape, the Xi-Trump meeting, everything. And, as leaders, we all face this prisoner's dilemma, because the world's going to look a lot different in 10 years. And from a conceptual standpoint, the question that these companies are trying to be the answer to is who owns you and who owns your company. And it's sort of how the internet evolved, right? If we say, and the US outsourced that to the private sector. So if we say who owns you, it's Google, Facebook, and companies like that. If you want to know who owns your company, it's Workday, Salesforce, and companies like that. And they extract enormous economic value for doing that. A lot of the profits that are generated in the world have moved to these companies that are the answer to those questions. The answer to that question is going to change. And it may be those same companies, it may be new companies. And that's a $100 trillion bet, because that's what's going to get created here. And we'll talk a little bit about that. But just to give some perspective, we're 1,200 days into this. Like if you considered the drop of ChatGPT 3.5 as the launch of the AI age, it's analogous to the launch of Netscape in 1994, which launched the internet age. So we're essentially in 1998. Google's not created yet. Facebook and iPhone are 10 years out. So to predict what the world's going to look like, again, 30 years out is very, very difficult. But there are some trends you can sort of look at. And I think in that first 1,200 days, you look at what we've learned, right? First of all, this is really game-changing technology, even in its first iteration. The competitive dynamics are intense, the stakes are high, the models are progressing very rapidly. The other thing we've learned at this point, it's no longer a science problem. Like, we know the science, it's an engineering and cost problem. Like a lot of the cognitive ceilings that we thought we had 3.5 years ago, where this tech is going to top out, have been solved. And now it's just engineering. How do you get this stuff cheaper, faster, broader, and continue to evolve the underlying technology along the science we already know? Costs are falling really rapidly. Tokens are the new currency that are replacing or enhancing labor. It's almost like the new oil. And it's like Moore's law, but faster. So if you think about Moore's law, over 50 years, chips got doubled their capacity and halved their cost every 18 months, right? So you went from this 4-bit useless processor 50 years ago into compute and memory in every single nook and cranny of our lives in ways we don't even realize. It's taken over the world because of that relentless 18-month march of improvement and cost cutting. If you look at what's happened in the first 1,200 days, Moore's law is happening every 3 months. We're seeing 50x improvements in inference costs and power every year. So if you took that 50 years and we maintained that speed, we're going to have that sort of impact in less than a decade, right? Plus, you have the software itself evolving much more rapidly, because in that Moore's law, the software was always a limiting factor. Software was expensive, hard, didn't work most of the time. That's gone. So that friction point is gone. So this is going to happen very, very fast. The other thing that you have to, the paradigm shift here, if you look at the last 80 years, we've had one computing architecture, and the innovation has been around compute and communication. Innovation has been around cost, access, communication. The internet and mobile was sort of the last stage of that. And the whole world's economy reorganized around this architecture around what you do for work, what you do for value equation, the economy, how we entertain ourselves. But what basically happened there is we made human knowledge work more productive. Humans did all the cognitive work. These were just tools that allowed it to happen faster. And you see the impact on the level of scientific innovation, particularly with the launch of the internet. Everything sped up just because we made humans more productive. The thing that's important about this is a completely different computing paradigm. It's around cognition. And it'll completely reorder the world economically, geopolitically, and socially. So if you think of the Industrial Revolution as replacing physical work, so if you went 200 years ago, or probably 300 years ago, 99.9% of the physical work in the world of moving things and molding things was either done by humans or animals we domesticated to help us at work. And that launched the Industrial Revolution to where we are today. Most of the economy is cognitive. And today, 99.9% of the cognitive work in the world is done by humans. We may use spreadsheets, we may use PowerPoint, email, these conferences, but this cognitive work is done by us. That's going to change. Within 20, 30 years, 99.9% of the cognitive work in the world will be done by machines with humans involved. And that is a complete paradigm shift. And that's why people talk about this as sort of the third technology wave in human history. First being agriculture, which moved us into farms, which changed how we organized ourselves, changed our government, social, it changed the nature of property, et cetera. Then the Industrial Revolution, which changed the nature of how we make things, energy, natural resources, colonialism, all those things. This is the third one. And there are few, and if you think of that first 1,200 days, it's sort of like, there's a great book called Rewrite Own, written by Chris Dixon. If you want to get a great history of the internet, he's a journalist, works for Andreessen. He's a great writer, storyteller. It's a great book, quick read. But it's called Read, Write, Own. And he talks about the first phase of the internet was the read phase. We all remember this, except for John. He looks very young. But back, when Netscape launched, the first 10 years, we just sort of read stuff on the internet like we were surfing. It was a very one-way medium. And then the second phase occurred, which really took off with the iPhone, was the write phase, where we could actually do things, right? We could talk to people, we could interact, we could pay bills, have a brokerage account, shop, et cetera. It was two-way, right? And if you think about this revolution, we've lived through the read age. ChatGPT, we asked it a question, it gives us an answer, right? And it's gotten really good at it. We're about to enter the write age, which I'll talk about in a minute, right? And that's this agentic world. But one of the other things we've learned from this read age of AI is what I call the collapse of the economics of expertise, right? So I've been obsessed with this benchmark, the HLE benchmark. Have you guys heard of the HLE benchmark, Humanity's Last Exam? So this was invented by this guy, Ted Kendricks, and Elon Musk one night. And they were dissatisfied with all the benchmarks. So they said, let's come up with a really cool benchmark. And so Musk said, well, to know AI is really intelligent, you need to pick a subject, take the top 0.1% of PhDs, take 1,000 PhDs, pick the smartest one, and it has to solve a problem that would challenge that person. So Hendricks runs with this, and he runs this competition, and they create 3,000 questions across 100 subjects. There were 1,000 academics involved from 500 institutions across, I think, like 50 countries, and 3,000 questions won. Let me give you one of these questions because it's really interesting. So here's a question from the exam. Derive the first law of black hole mechanics for a rotating curved black hole and explain its analogy to the first law of thermodynamics. Then evaluate the philosophical implications of this analogy for theories of emergent space-time. That's why it's not even the hardest question. When this launched last year, the best model, which was DeepSeek and I think ChatGPT's, could answer about 3% of these questions. We're 14 months later, they answer almost 50% of the questions. And what that means in another year or two, you're going to have this level of expertise available in 100 subjects around the world for less than the cost of water. And in terms of one thing this is going to change, if you think about our economy the last 200 years, it's really the expert economy, right? Every economy has a social contract, which if you follow the rules, you're going to do okay. So it used to be in the industrial age, go to school, K to 8 or 12, get a job in a factory, join the union, you'll be fine. In our age, it's been do well in high school, go to a decent school, develop a narrow band of expertise that has surplus value in the economy and charge for that. Accountant, programmer, estate planner, you pick it, right? Because expertise was expensive, sporadic, and hard to get access to, and expensive, and hard to get to. And that expertise created friction throughout the global economy, right? And it created advantages for people that had the expertise and people could have access to that expertise, give you competitive advantage. That model's done. It's going to go from expensive, sporadic, and inconsistent to cheap, ubiquitous, and consistent, and top 1%. that changes everything in the economy, right? And if it can master curve black holes and emergent space-time, it's not going to have a lot of trouble with estate planning, right? And you're starting to see that happen. So that friction in the economy is gone. And that's going to dramatically change our social structure, our social contract with people. Different skills are going to be valuable, other skills that have been valuable. I make this joke, like if you were good at math the last 40 years, you were guaranteed a place in the middle class. If you were really good, you're in the upper middle class. If you're in the top 1%, you're the new aristocracy. You just had to be good at math. You didn't have to be a good person, didn't have to have personality, just had to be good at math. And that was our economic model. That's gone, because those skills will not be nearly as valuable now. And there are implications for that, right? So we've gone through this age, the first 1,200 days. We've learned a lot. What's going to happen in the next 1,200 days? And it's a lot. And I'll just list out a bunch of things, but we'll focus on a couple. You're going to start seeing things like domain-specific LLMs, stuff that's focused on health, or even just cancer research, or even just solid cancer research, or even just pancreatic cancer research. You're going to see a lot of these get developed quickly. You're going to see hyper-personalization, where this thing is much more anticipatory of what you're trying to do. You're going to see sovereign AI, because geopolitically, to not have control of this technology is not a good place to be. You're going to see search change to AI-based search. The three I'll focus on today are coding models, agentic AI, and science AI, which you're going to start hearing more about next year. So coding models are interesting because to me, it's sort of the canary in the coal mine. It's the bleeding edge of what's going to happen to expertise. And it's teaching us some of the dynamics around the falling cost of expertise, ubiquity of it, and its impact on the existing labor force that had that expertise, that was selling it at very high prices. So, a couple of years ago, AI could barely write code. Right now, it's equivalent, and then within a year is equivalent of probably somebody graduating undergrad. It's rapidly becoming at the level of your CTO of a large software company. It's not there yet, but it will be in another year or two. This stuff is accelerating at light speed, and you can see in terms of the prisoner's dilemma, the speed with which these companies are developing that, because that's where the money is right now. And so, it's why Anthropic has shot past OpenAI in terms of valuation, and its revenue has now gone from, I think they're running at a $50 billion run rate. Ironically, like when it comes to the jobs question, some people say it's going to destroy a lot of jobs. Some people say it's going to create an incredible number of jobs. Frankly, no one knows. Like historically, technology has replaced lower placing jobs with higher placing jobs. It's created massive wealth. It's created better distribution of the wealth generally. Maybe that's going to happen here. Maybe there'll be this massive job destruction and unemployment. What we do know is there'll be a huge shift in employment. I grew up in Pittsburgh in the 70s, worked in a steel mill, and there was a social contract with people. They worked in the steel mill. When the steel mills closed, that collapsed. And it wasn't that there weren't other jobs created. It was just these people weren't equipped to do those jobs. So they went from the middle class to the lower class, like overnight, instead of making that transition. I think you'll see some of that here, particularly with elites. They have expertise they spent years and years developing. That expertise will no longer be valued. So we have to shift to something new, or, there'll be problems. The other area is, let me talk about science AI, because that you're going to start hearing more of, where there's a lot of AI being developed around creating AI scientists, where the AI can propose hypotheses, develop experiments, run the experiments, actually run wet lab work with robots, and iterate on that very quickly. You're starting to see the early pieces of that around research. I read an article the other day. It was some healthcare research where they were, their usual process that they went through would have taken about 2 years and cost several $1 million. And they did it in 4 hours today with today's technology. And somebody told me there's 100 drugs about to hit the FDA that were AI generated. And this stuff now is frankly pretty crude. So you're going to start seeing this stuff evolve very rapidly across hundreds of areas of expertise where you have AI scientists with humans assisting, pushing science very quickly. And if you are the top 0.1% of expert in your area, this is a force multiplier. Like if Einstein had this technology at his fingertips, he'd have done 300 years of work in 10 years. Because it's just such an ability to expand your cognitive abilities and have the AI do so much of the work. So I think, we're going to start seeing centuries of innovation in less than every 10 years across everything. The last piece I'll talk about, which is probably the most important, I think, is this emergence of an agentic economy. Like you've probably heard in the news, these agents are writing code, these agents are running rogue, these agents are doing this, and that. And the agentic shift is really our equivalent in this age of moving from read to the write age. Because up to date, we've been in the read age. You ask ChatGPT a question, it gives you an answer. In the agentic economy, this stuff does stuff for you. Like you say, I want to plan a trip to, London. And this thing goes out and plans it for you. It actually takes action on your behalf. And this agentic economy is really what everybody's racing for. The ChatGPT stuff is nice. You can ask it a question, get an answer. But the agentic frameworks are going to rewrite the economy. And this is where the cognitive workload is going to move from humans onto machines. And what's interesting about this is if you say, I want to plan that trip to London, the agent actually doesn't do it. The agent organizes it, your agent. And it might even be your personal agent talking to an agent that does London trips. And the London trip agent says, okay, we need to check the weather, so give me a weather agent. We need to check the flights. We need to book the flights. We need to get a hotel. We need to plan this. And it may trigger 1,000 agents doing little tasks, solving this problem for you. And you just basically get a trip on your calendar and tickets and reservations that you decide, just do it for me, or I may approve. Give me 2 flights, I'll pick one, that sort of thing. But the agents already know how to do this. Now, the implications of that are really interesting because you're going to replace, a lot of human labor. You're going to replace a ton of friction in the economy. You're going to free up massive amounts of your time. You're going to lower the cost of all these services dramatically because the economy is just going to get more efficient and there's a lot of costs are going to be wrung out. But it's also going to create this whole alternative world of agents that frankly runs its own economy. And 99% of these agents that get created will never talk to a human ever. They may not even know humans exist. They just operate. And they compete with each other. And they compete for money because to survive, they need compute and memory. And they have to compete for that. So if you have 5 agents and one's really good at booking a London hotel and 4 aren't, those 4 agents will disappear. So it creates this very evolutionary competitive dynamic in this world. It creates, frankly, wealth transfer to this agentic economy as they accumulate money and resources. And you'll start seeing startups that one-person startups that they're building an agent that never interacts with a human. It just becomes the world's greatest London hotel booking agent. And it extracts 1/10 of a penny each time it books a London hotel, right? And that'll accumulate wealth for that one individual. And at some point, you're going to see AIs, because the AIs are smarter than the humans, creating their own agents. You're going to see billion-dollar companies that don't have any humans involved and accumulating wealth. And that is going to, change how we deliver economic value around the world and how that economic value accumulates. And it's really hard to get your head around this. Anybody says this is what it's going to look like 10 years from now, I mean, who knows? It's very unpredictable. And I think, so if you look at the world we're going to create, the good news is we'll have radical abundance. If the definition of wealth is a delivery of a wider range and higher quality of product services around the world at lower cost, we're going to see wealth explode. And we saw this in the internet. Like if you look at the internet revolution, created probably about 500 trillion of wealth, right? Over 90% of the world's wealth didn't exist 30 years ago. Took global poverty from 40% to under 10%, actually reduced income inequality and wealth inequality around the world. We don't think that, but it actually reduced inequality about 14% around the world. And really did a great job of distributing that. In individual countries, it may not have done as good a job, but overall, globally, it did. And we're going to see 10x that in probably less than 30 years. So, in every other sort of economic shift, there's been some new source of scarcity that we fought over, and it was sort of the source of our tensions. We moved to when we were hunter-gatherers, we fought for hunting areas. When we moved to agriculture, we fought over land and water. When we moved to industrial, we fought over resources and energy, because the source of scarcity moved. And this is going to be a world where we don't really have that scarcity. So sort of a problem like we've never dealt with before. That's the good news. It's still a problem because people, how do you distribute that? If we create this huge abundance of jobs, work will be the method we distribute it like we have in the past. If we don't, and there are 100 trillionaires that control everything, we've got a wealth distribution problem we're going to have to deal with. And nobody really knows what that's going to look like. And if you look at a lot of our economic life now, it's built on consumerism, debt, et cetera, and this expert elite model, which confers status, power, money. And a lot of that's going to get blown up. And so that has opportunity to create instability, but has an opportunity to create a much better world if we do a better job of distributing the wealth. And, I thought about, as if I was running a government, like I'm not an you guys are experts in New Hampshire, I'm not. Like I know much more about California and the issues we're facing. How do you sort of prepare yourselves for this? And I think there's great opportunities. Like if you look at California, the California economy is about $4 trillion, and the California government takes in about, the public revenue from all that's about $1 trillion. So about 25% of the economy goes to either the state government, schools, utilities, things that are sort of in the public sector. And if you just took that and applied AI to our issues aggressively and eliminated the fraud and inefficiencies, it's hard to believe you wouldn't free up 20% of that. And $200 billion a year that could be spent on, real problems. So I think there is an opportunity for states to apply AI to themselves, one, to learn its implications, create efficiencies, access for the population services. The education implications are huge. Like education is going to change dramatically. So how do you sort of look forward and apply this technology to make K through 12 more efficient, make your universities more efficient, or change actually the social contract of how people get educated? And then it's a question of how you build your economy. And I think there's been a clear sort of principle that we've learned over the last 30 years, that if you look at the economies that sort of get the fundamentals right, property rights, social services, et cetera, and then what's the differentiator to success, it's been those economies that over-rewarded risk-taking. Like because we're in such an innovative world, and entrepreneurs tend to be the vehicle that innovation gets implemented around the world, those countries, and frankly states that over-rewarded risk-taking, tended to leap way ahead of everybody else. And so if you look at Europe and the US 20 years ago, we're about the same, right? But the difference was, and I was a VC in Europe for a few years in the late 90s, so I knew that market pretty well. But they were actually punishing risk-taking. Both you were punished if you failed and you punished if you succeeded, and they made it difficult to succeed. Whereas the US and China basically over-rewarded risk-taking. And we all started at about the same place. Right now, if Germany, the UK, and France became states, they'd be the three poorest states in the United States. Like there was a big disparity in wealth creation, economic success, and China was the other country that overrewarded risk taking, and we saw how they've done. And I think that becomes even more important going forward, right? Over the next 20 years, as risk taking will become even more valuable as these technologies really transform the economy. And I think that's relevant at a state level as well. Like, do you attract the people that are going to drive the change and develop these innovative technologies that are going to attract a lot of the wealth? One opportunity which we're starting to see out here is because the cost of software development is so low, you're starting to see these 1 to 5 person software startups. You're going to see a lot of micro software companies that do 1 to 10 million of revenue, right? Have 5 employees. They're lifestyle businesses. VC will never back them, but they'll generate very high income households. And those companies are not going to be in California. They're going to be in states like Texas. They're going to be states like Florida, just because and states potentially like New Hampshire, because you guys have a very attractive potential economic framework for entrepreneurs. So I think it's going to be a huge source of income and wealth shift as these companies emerge. Particularly, we're seeing people getting laid off from Meta, and they're all starting companies. Sometimes they're starting 2 or 3 at a time because it's so easy now. And again, they won't be big businesses, but they'll be great lifestyle businesses. And those people aren't going to stay here. It's too expensive, too hard to live. They're going to go find places where they can have a better quality of life, I think. So I can go on and on, but I want to stop it so we can open it up for questions. That was a lot of topics very quickly. Hopefully that was helpful.
That was a lot of topics. And there's one dangling thing out there that I just wanted to ask you about. You said read, write, and own. And you applied read and write to the AI progression. Where does own fit into the AI progression?
Yeah, so Dixon runs cryptocurrency at Andreessen. So the thing that happened, I'll give you like the quick rundown of his book, which I agree with. So when you had the read era, this was all built on open protocols, HTTP, SMTP, et cetera, which were available anywhere. And for read, it was fine because you weren't putting your information on. The write area was built on these same protocols. And the problem with these protocols is they're a security nightmare. I mean, we just live this every day. And 2 things happened. And this is probably the primary reason we had such a wealth shift to, the SaaS software companies and Google and Facebook, because 2 things happened as a result of that. We built this $1 trillion cybersecurity industry to protect us against these idiotic open protocols issues. But the second is we created this feudal system. Like, think about feudal times. You farmed your land, but you had a castle to go to and hide behind the walls. Those castles for our personal information became Google, Facebook, Apple. And for corporate information became Salesforce, Workday, and those companies. So who got rich? The baron that owned the castle. And so there was tremendous transfer of economic value from we serfs to the barons. And to give you a sense of that, like if you put $100,000 in the S&P 500 20 years ago, it'd be worth about $500,000 today. If you put $100,000 in just the 7 public gatekeepers at that point, this isn't Facebook or Workday, or they weren't public yet, just like Google, Apple, Intuit, Adobe, you'd have $12 million versus 500,000. The S&P went up 5x, but that all went to those. And if you actually take the difference between us and Europe and you take the gatekeepers away, we did about the same. 100% of the difference between us and Europe in economic performance is we encouraged risk-taking, built the gatekeepers, and Europe didn't. And China built their gatekeepers. So his premise is that the crypto, which is true, gives us the opportunity to take that back, because crypto, if you don't listen to the hype, crypto actually gives you a set of secure protocols where you don't need the barons anymore. You have control of the information, you have provenance around your identity, et cetera. And so it's a software architecture that takes away a lot of the issues. It eliminates all the issues with the open protocols. It frankly can eliminate most of the cybersecurity industry. You don't need it anymore. And that was his premise. Now, I think we're moving from read, write, know, K-N-O-W, like it's going to go from right to just know things. But I think there's three models of who owns you and who owns your company. One is the private sector, which is the US model. One is the government, which is the Chinese model. And the third is the crypto model, where you own you. And to give you an example of what crypto can do is, one, it gives you provenance. Like in another year, I won't even know you're real people. You could be all North Koreans like that attracted me to this seminar to find some information to steal my money. Like, I don't know. Whereas crypto solves that, because I would know Thomas Corman's Thomas Corman, because there'd be a cryptographic exchange that I know that's actually him. Or how do I know that New York Times article is from the New York Times? The other thing it does, it lets me control my information. So if you look at an Experian in this world, like Experian now collects all our data in one place, runs our algorithms on it, and all you have to do to sell our data is break into Experian. In the crypto world, Experian is just an algorithm. Our data is encryptically owned by us. If Experian wants our credit score, it sends the algorithm. We send back our score via their algorithm. That's all they know. They don't even know who we are. And that's sort of in a simple way is how crypto works. So my premise is, there is an alternative to this world of private sector government in the AI age, which is now it's going to be a $6 quadrillion question, not a $600 trillion question like the internet. It's a $6 quadrillion question. Almost $1 million for every man, woman, and child on Earth. Is it owned by them, or is it owned by you? And Dixon's premise would be, we need crypto to work. And the two bills that are hopefully the Genius and Clarity Act. The Genius Act dealt with stable coins, which I think is a very good bill, actually. And the Clarity Act is actually also a very good bill, really well done. It'll bring that industry back to the US, and you'll start seeing a lot of innovation around, forget meme coins and all that. I'm talking about like cryptographically secure architectures that you as the user own, not some company that got backed by Sequoia, right? And you're starting to see this, you have some of these companies going after like DoorDash, Uber, where the network is owned by the participants in the network. So that's really what he was talking about. That's a whole other discussion, but I think it's very interesting. And you're starting to see this in AI, where you're seeing networks like BitTensor, which are distributing compute. So as opposed to going to Amazon or Anthropic, you can go to these networks and it's about 1/10 the cost.
Very cool. We just open it up to questions. Anybody want to just chime in and just keep it going? Go ahead, Dom, just speak up.
Yeah, thank you, Keith. Nice to meet you, Doug. I think the first place I would want to go with this is, and we're a bipartisan caucus, but I think necessarily I will delve into some partisan question here, because what you just described, you talked on the one hand about the openness, the peer-to-peer nature of protocols historically as being a bad thing, which I would profoundly disagree with. But then you talk about some of these blockchain solutions being perhaps, for ways of the future that are kind of bringing things back to the individual and to more of a peer-to-peer model. We see at the moment with these capabilities that you just outlined that there are meaningful and material national defense considerations, and that the sovereign interest will continue to be very significant. And we also see that just the nature of the compute necessary is at least for the larger models, going to put a material lower bound on the resources needed that does centralize a bit. So when I think about the fact that over the last couple of decades, we've seen a very, very material shift to the left in the tech industry and to centralization in the tech industry, how do you see that competing with the sovereign interest, with the sort of distributed blockchain interest that you're describing?
Yeah, I think those are all really good questions. So I think on the blockchain piece, and believe me, I love the open protocols too, because it helped me like create a life and a career around those open protocols. The problem with the open protocols is there's no incentive to develop them. And so a lot of problems people know about, it's hard to sort of deal with those. We've done that sort of on there's no sort of competitive dynamic. I think properly designed. If you take away the word crypto, because the crypto piece really is just used to secure the network, it's really just a secure protocol, like that everybody agrees to, and you have an economic incentive to support it and develop it. But it needs to be regulated. The problem is it's been totally unregulated. So we just regulated stable coins in the US. So now you have stable coins backed by treasuries. You'd have to be a moron to use a stable coin not backed by treasuries. So just the regulatory framework is going to move capital to, coins we know, which allow us to sort of isolate the coins that aren't using treasuries, because you'd wonder, why are people using them? So I think it sort of flashes a light on that part of the market. I think in terms of the resource thing, it's an issue. I'd say, the good news is so there's this dynamic where the inferencing is getting is increasing in efficiency extremely fast, like 60x a year, maybe even 100x a year. And inference just generates tokens. The token generation is getting much, much, much cheaper. The challenge is the demand for tokens is, a tiny, tiny fraction of what it's ultimately going to be, because reality is people really aren't using this technology that much yet. So the need for token usage is going to go crazy. So then it gets to, okay, can we afford all these data centers? Because they're enormous. Basically, electricity is what they use. That's really the resource that they consume. They don't really use much water, but they do use a lot of electricity. And the same time, countries need to have the data centers on their shores. Like geopolitically, we can't be running our economy off data centers, even in allies. They've got to be here. And every country's going through that. That would be dangerous. It'd be like having our electricity pumped in from, one country. So we have to have those here. Then you get into this dynamic, okay, my state doesn't want it, but this state will. I think these data centers will probably migrate to where energy is most efficient. If I look at Bitcoin mining as an example, it tended to migrate where the energy was cheap, or where it could sort of even make the energy cheaper because it would equalize the grid. Like in Texas, Bitcoin actually makes electricity in Texas cheaper because it soaks up energy in downtimes and drops off in uptimes. But energy is going to be a big issue. Do they end up in space? Maybe. But and every state, I think, has to make a decision. The thing with data centers is there's two schools of thought. Data centers don't employ a lot of people. So why do we need them? Like, why have them? Like, it's not like it's going to attract a lot of software talent and a lot of people to my state, like a laboratory would or university. Then another school of thought is, well, people are probably going to migrate to where the data centers are, because you're just going to have a talent there. It'll be like a snowball effect. I don't know the answer to that. And so I think every state just has to make the decision. I think there'll be enough states that embrace them that will have enough capacity, in the US. I do think they end up ultimately in space, just because of the energy issue. But that could be 20 years from now.
Representative Corman, you have a
Did
question?
I cover all your questions? Hopefully I at least touched on.
Well, I'll come back on it, but I want to let Representative Corman go first.
Okay.
Ken, thanks. And it's interesting. I don't always agree with Representative McFarland, but in some cases I do. I don't know about the leftward shift on tech, though. It seems like the tech bros have been cozying up to the current federal administration.
Let's keep the partisan talk at a minimum for
but
everybody.
What I do want to talk about is the data centers, and I'm glad that that's been brought up, because it's not just a matter of energy, it's also a matter of how they're cooled, the noise that they generate, things like that. And I'm pretty much on record as not a fan of data centers in New Hampshire for those reasons. If we could solve all of those reasons, and I love the idea of putting them in space where they can't make noise, where I think cooling should not be a problem, although I don't know about that. The other concern I would have about building data centers, at least in New Hampshire, is that they actually don't provide that many jobs. And I don't see why people would need to migrate near data centers. But certainly operating a data center does not really create jobs other than the temporary construction jobs. And frankly, I'd rather see those go toward building the housing that we desperately need.
Yeah, I mean, I can't argue with that. Like, I think every state has to make a decision. I think, sort of stepping back, I think you may, and I'm sure you guys do this, but what I would think about is like really understanding, okay, given these trends, we need to skate to where the puck's going to be. What's the economy going to look like? How do we want our state to fit into that? How do we set that up? Which is probably, frankly, more important than the data centers. Like, I think, and the needs of New Hampshire are very different than the needs of California. So, frankly, I worry about California because we're shifting to this environment where we're going to punish risk taking, and we're already seeing flight out to places that don't do that. We're in a different dynamic because they're trying to build trillion-dollar companies here. New Hampshire probably isn't. So I think there's a real opportunity for states that are forward-thinking to carve out their piece of the economic pie that's consistent with their values, their economy, their environment, the sort of things they want to do. For New Hampshire, it may be, okay, I want to, in the next 10 years, attract 1,000 micro software businesses. What do I need to do that? And what are my advantages? I'm an hour from MIT. I have Dartmouth. Or it might be biotech, or whatever your unique strengths are. And then how do we organize to do that? Because I do think talent is going to be a lot more mobile than it was in the internet age. People are going to leave. You're going to see a mass exodus from California because it's just too expensive here. And it's going to be, we're already seeing a dynamic here, which is very strange, which we'll start to see elsewhere, where, the people making $1 million a year are getting pushed out, because there are people making 10 million a year in the AI industry coming and knocking on their door and literally buying their house. And that person making $1 million a year just got laid off from Facebook, right? And this is a super talented individual that could easily start a company in their sleep. So, I think that might be a bigger issue than the data centers, because the data centers are sort of binary. And I know New Hampshire energy is expensive, so it's probably not the first place most companies are looking at anyway. But that picture of what you want to look like, that's in your hands. And I think there's a huge opportunity for smaller states, particularly with your beauty, your environment, your size, to grab a pretty good share of that pie.
Well, and you asked me whether you'd attended to my questions. I think I probably was unfair to you with the breadth of my question, because there are a lot of topics. But I put it to you that the interesting question here fundamentally is where you think things will end up. And you've been very measured in your responses. You've been sort of acknowledging that there's a number of different directions that things can go. But what sort of comes to mind relative to some of Representative Corman's comments is we are currently facing a scenario where, of course, historically, New England is never going to get a meaningful data center because its electricity is ridiculously high, and because in the particular case of New Hampshire and like Maine and Vermont, we are nowhere near in the middle of the key data center networks, the backbone networks. But something you said, I think, is worth drilling into, which is the economy that we thrive on is ultimately dependent upon energy. And if we do not consume that energy for productive purposes in our state, then our GDP does not increase and maintain either. And so, we can talk about, well, what does it mean when these things are out in space, and whose sovereign territory is that, and who gets to tax it?
Mm-hmm.
But one of the advantages that New Hampshire does have is with regard to the privacy and the taxation of the workloads that are in the data centers. And so I think what I would like to ask is, where do you foresee the various states diverging on taxation policy and other policies that have a material impact on the placement of data centers and workloads?
Well, I think they're going to tend to be in the red states. and that's not a partisan thing. It's just the economic incentives. Like there's a concerted effort on the part of those states to attract talent, right? And Texas in particular, we feel that a lot here. Florida less so here, but I have a lot of friends that have moved to Florida, Tennessee. Those states are a lot of the future economic wealth generation is moving there pretty quickly. As a side piece, they're building data centers like we're building in Arizona. So I think between us and TMC, we're going to spend $200 billion building capacity north of Phoenix. Like if you ever go to Phoenix, just go drive by these plants. They're science fiction. And I just met with the head of water in Utah and the head of I think he's head of commerce, who talked to us about how they dealt with energy and how they are dealing with water. By the way, I learned something interesting. Arizona uses less water today than they did in 1957, with 6 million more people and 30x the GDP, which was quite interesting. But anyway, they're building data centers. Their viewing power is not the issue. And now their decision to do that is they've sped access to West Texas gas, but nuclear is where they're headed. They've greenlit a nuclear plant. They've given us assurance the power will be there. And I think that's probably where they're going to go. And this is a state that gets sun 365 days a year, and solar's a piece of it, but solar can't scale properly, right, for us, even in Arizona. So, that's why if you heard the podcast, I was saying probably nuclear is the right answer over time. And the nuclear technology seems to be progressing pretty quickly. And, one of the side benefits of this is the data center business itself is accelerating the development of nuclear in a way that I think will benefit all of us. And, all these projects that have been sitting there forever are now getting sped up, these small nuclear reactors. And that could be, the problem could solve itself, right? So I tend to be a little bit optimistic, but I also know that economic incentive can really drive behavior and you just have to monitor it so it does it in the way we as a society all want to happen. But I think that's happening there.
I want to give it just a shameless plug, if you don't mind. I want to put a op-ed that I wrote recently, and it's all about this. and to me, it seems like the future of pairing small modular reactor, advanced nuclear, with a demand that can sustain the project, right? It's like kind of like peanut butter and jelly when you think about it.
Yeah, I mean, we in TSMC are paying $200 billion just building the plant. Like if we could build nuclear next to it for a couple billion, that would be pretty smart, right? And right now we're tapping to the grid where they'd expand the grid for us. If you looked at this thing, it's impressive. And they've assured us the energy will be there. But so I don't know if I answered your question, but I think the energy problem probably gets solved. Hopefully it gets solved fast enough. It is every aspect of the infrastructure build out is on allocation, whether it's a memory chip, whether it's cement, whether it's fiber, like everything's on allocation, but everybody views probably the ultimate constraint is going to be access to the energy, so it is a big issue.
So we're just doing a time check here. We're coming up
and China does not have that problem. Like
we're coming up on
they're
3
not
minutes to the hour. So just want
to
I think we need to wrap up and we'll continue the conversation online if we could. So Doug, thank you very much for your thoughts on this. I mean, you're obviously very well versed in all these issues, and it's very fascinating. I think things are happening very quickly, and that's kind of the point of this caucus is we need to get ready, as you said, skate to where the puck is going, but at least be educated on these rapidly changing issues. So how can we get a hold of you if we wanted to ask you more questions or listen to the next podcast that you're on?
You can just email me. Like, I'm not selling a book or selling anything, so I do this, I do this for Terry, and I'm really, honored that you guys would take the time to listen. And, I think that, it's great that you're on this, and I think there's probably a big opportunity for your state, given, all the changes that are happening, but there's also risks too. So it's great that you guys are getting ahead of it.
All right, excellent. All right, any quick final thoughts? Or Tom, do you want to just state your background? We didn't do introductions in the beginning, but you have an interesting background.
Yeah, so I'm an emeritus professor of computer science at Dartmouth. I'm the lead author of Introduction to Algorithms. I always keep a copy in my pocket. There it is.
I got one of those.
Yeah, I gave one to Keith. And I'm a deputy ranking member on Science, Tech, and Energy.
Very cool.
We should have had Tom give the talk.
No, I don't think so.
All
I
Well,
didn't
thanks,
do work on
everybody.
AI. I did work on algorithms and gray codes, but not really AI. So
You guys
I'm-
could talk
I'm-
about neural networks, right?
Yeah.
That's probably
I
Just,
never really worked on neural nets. I'm really learning a lot about AI here. But the thing is, I've been tracking it for 40 years, over 40 years.
I think just to
Yeah, it's an
summarize,
overnight success after 40 years of work. Right?
Yeah.
yeah.
I found, I was just say, Doug, I found the prior podcast I listened to, I had dozens of questions. Now I've got, 10x that. So again, I may reach out to you with some questions over time, but really appreciate your just expanding our minds and blowing them, frankly. So.
No, that's fine. If you ever want to do this again, just reach out to me. I'd be happy to do it. I think what you guys are doing is super important. I hope every state is doing this, given the changes that are going to occur. So great.
Awesome.
Okay. Thank you guys.
All right, everybody. Enjoy the rest of the day.
Bye-bye.
Thanks, Doug.
Thanks,
Appreciate it.
Doug.
Thanks, Terry.
Bye-bye.
See you guys.